Okay, today we're going to learn about systems of equations. So, system of linear equations, and we're going to learn how to solve them by graphing first. So, a system of linear equations is when you have two or more equations on a coordinate plane, or you're solving two or more equations for a common point. Okay, we're only focusing on two, we're not going to focus on more. So, a solution is an ordered pair that lies, which is a point which lies on both lines. So for example, determine whether the point is a solution to the system. So we're going to use the point -3 and 1, and we're going to use these two equations, x minus y equals -4, and 2x plus y, 10y is equal to 4. So we're going to substitute in -3 for x and 1 for y and see if it's true. So if we substitute it in the first equation, -3 minus 1 is -4, so that makes it true. If we substitute it into the second equation, so we have 2 times -3, which is -6, 10 times 1, which is 10, so -6 plus 10 is 4, so that statement is true. So when we substitute in the values, we get -4, or excuse me, we get the solution for each one. So -4 for the first one, and 4 for the second one, so that means it is true. Okay, we're going to determine whether the following point is a solution to the system. So 4, 2, and we're going to put it into 2x minus 5y is equal to -2, and 3x plus 4y is equal to 4. So we're going to substitute in 4 for x and 2 for y. So in the first equation, 2 times 4 is 8, minus 5 times 2, which is 10, and that's -2, and that is true for the first equation. And for the second equation, we substitute in the 4, so 3 times 4 is 12, 4 times 2 is 8, 12 plus 8 does not equal 4, as stated in the equation up there, so that is false. So this point 42 does not lie on both equations, so therefore it is not a solution to the system. Okay, so that's using substitution to find the point, but this is the problem you're going to be given. This is what we're working more on. Okay, so since the solution needs to be a point on both graphs, right, we need to solve the system to figure out where they cross or where they intersect. So if you're given the first equation, 2y is equal to 6, and that's this line here, 2x minus 6, 2x minus y is equal to 6. And the second equation, okay, is x plus 3y is equal to 10. You can find points for both of them to be able to plot the graph on the coordinate plane. So if you're doing this on the calculator, obviously solve for y first and then graph it, right? But we will give it to you in all kinds of forms, standard form, not quite in standard form. And your job is to figure out how to graph that line. We worked on that right prior to vacation. And if you need more practice on that, I can provide that, being able to graph a line. So if we look at this, it looks like they cross at 4, 2. So that would be the possible solution point. That would be the possible solution point. But we need to take this point 4, 2, and we're going to substitute it back into the equations to see if it is the solution. So we're going to take x equal to 4 and y equal to 2 and plug it into each equation. So the first equation, 4 times 2 is 8, minus 2 is equal to 6, and that was true for the first equation. And the second equation, we have 4 plus 3 times 2, so we have 4 plus 6, so that's equal to 10, and that is true for the second equation. So the point 42 is the solution for this. We are also going to use the calculator to do this a little bit later. So it works out as a solution. So let's look at this in the next example. We're going to graph these two lines given by these two equations on the coordinate plane. So the first line, we found the points. We graphed our line. Second equation, we found various points and graphed the line. It appears that they do not cross each other. It appears that they do not cross each other. So that means they would be parallel lines and there would be no solution. Well, to figure that out, we're going to have to take the two lines, which we believe to be parallel, and solve both of them for y and check the slope. So solve both of them for y. So solving the first one for y is equal to 1/3 x plus 2. Second equation, y is equal to 1/3 minus 1. So since they have the same slope with different y-intercepts, there is no solution to the system. They are parallel. Okay. Now follow this system, these two, right, graphing. Okay. So we put in points for the first line and put our line in. And then we're going to find points for the second line, and they lie exactly on the same place. So they appear to be identical lines. So that means that they're on top of each other. So what that means is that we can solve for y and see if we get the same equation. So y is equal to 1/3 x plus 1/3. Second equation, y is equal to 1/3 x plus 1/3. So they are exactly the same line. So there's an infinite number of solutions that the lines are laying on top of each other, coinciding. So if there are coinciding lines, there's an infinite number of solutions for those. Okay, so let's quickly review 3 possible outcomes that we can have for a system of equations. We can have one point of intersection, so there's one solution. You can have parallel lines, so that there is no solution, and coinciding lines. So there's an infinite number of solutions. That means the lines are on top of each other, they touch everywhere, and there are an infinite number of solutions for that. Okay? All right, so that is solving systems using graphing.